Electric current. Electric current is the rate of flow of charge flowing through the conductor, resistance or whatsoever it is. It is rate of flow of charge, coulomb per second. SI unit is ampere. 1 ampere becomes equal to 3 into 10 to the power 9 stat ampere. As in the case of coulomb, 1 coulomb is equal to 3 into 10 to the power 9 stat coulomb. Current is a scalar quantity, although it has the direction, but it does not follow the law of triangle and other fundamental laws of vector. On that ground, we assume that current is not a vector. You see, current might be uniform, it might be variable, it might be 0, and for all the 3 cases, we follow this type of graph. The area enclosed by this IT graph is going to be equal to the charge flown, and when this is only Q, you are having the idea of current. Here if it is QT graph, it is giving you the idea of current, and if you are plotting the graph between I and T, its area is going to be equal to the charge flown in the circuit. Current flows in the metals by the free electrons, in the electrolytes by positive and negative ions. In semiconductor, you see electrons and holes created, both are responsible for the conductivity, whereas in the case of gases, electrons and ions both are responsible. Current is basically of 2 types, DC and AC. Direct current, you see, direct current is the current having direction throughout same, and alternating current, it has the variable direction. AC represented by this symbol, sine wave, it is also said to be sinusoidal. DC is given this way also, and if it is a variable DC, you could represent it by this letter. Suppose the charge is circulating, then in that case the I, the value of current becomes Q upon time period, and time period could be written as 1 upon n, 1 upon t is equal to n, this becomes Q. Omega angular velocity upon 2 pi, and this omega could be written as 2 pi upon omega. So, you can write in different forms here. And finally, we want to find one relation for the current flowing in the conductor. Suppose the conductor has the area A and the length is L. The volume is going to be equal to area into length. Suppose the velocity is v, then in t time the length covered will be given by v into t. Let's suppose there is n charged particles, each particle having the charge q, n particles per unit volume, then the number of charged particles in the volume v will be given by n into v. You see, number of particles in the given volume is going to be n into v, that is n a l. Every particle is having the charge q. So, the charge flown, better use the letter capital Q for the total charge. Total charge flown will be given by n to q, and that means n a l q. This L could be written as v into t, it is going to be v t q. Q upon t, that you know as the current, this is going to be n q a v. This is the formula for current, and if you are interested in writing this equation for metals, there v will be replaced by drift velocity, and this charge q, since the carrier there are free electrons, so in place of q we are going to use a small